Okay, in this video we're going to do a few worked examples from the chapter review. Make sure we can understand how to do those sorts of problems. Okay, the first one we're going to do is question 2 from the chapter review. Question 2 says, a ladder that's 4.5 meters long rests against a vertical wall. Let's draw a picture of that. So we've got a ladder, it's resting against a vertical wall, and we know the ladder is 4.5 meters long. The foot of the ladder is 2 meters from the base of the wall, so this distance from the base of the ladder to the base of the wall is 2 meters. Okay, and since we can assume the wall is straight, then we know this here is going to be a right angle. So the angle the ladder makes with the wall to the nearest degree is going to be what? The angle the ladder makes with the wall. They must be referring to this angle here. The angle the ladder makes with the wall. So we've got to find this angle here. How can we do that? Alright, we've only got 2 bits of information and it's a right angle triangle, so that tells me this is going to be a Sohcahtoa problem, not a cosine or a sine rule problem, because for those we need 3 bits of information and they don't you don't apply them to right angle triangles. For right angle triangles you use Sohcahtoa. Okay, so this is our unknown angle that we want to find here. And relative to this angle, this side here would be the hypotenuse, and this side over here would be the opposite. Okay, so we're working with the angle, the hypotenuse, and the opposite. Well, that's obviously going to be a SOH situation. So let's write out that equation. Sine theta equals opposite over hypotenuse. And let's put in our values. The values we've got, we don't know theta, so we're going to leave that. But we do know the opposite is 2 and the hypotenuse is 4.5. And we want to find the angle, so we've got to get rid of this sine. The opposite of sine is inverse sine. So apply inverse sine to both sides. Inverse sine of 2 divided by 4.5. Let's put that in the calculator. Okay, here's our calculator. Let's find the trig functions. Inverse sine, 2 divided by 4.5. Close the bracket. And it's 26.39. 26.39. And since our units were in meters, actually it doesn't matter that they were in meters, but this is an angle, 26.39. But we should really convert that into degrees, minutes, seconds, shouldn't we? So here's our answer again, 26.39. Let's go interactive, transformation, and change it to degrees, minutes, seconds. And there we go, 26 degrees, 23 minutes. 26 degrees, 23 minutes. Okay, so there we go. Now, we've got to choose one of the responses. This is a multiple choice question. So when we've worked out the answer, it's clearly closest to answer B. So that's that one. Alright, now in this next problem, this is question 3 from the multiple choice section. We've got a person standing 18 meters from a building. So let's draw that situation, 18 meters between the person and here's the building. And this person measures the angle of elevation to the top of the building as 62 degrees. And if the person is 1.8 meters tall, how high is the building? So the height of the building is what we're after. Now this is a slightly ambiguous question because it's saying the angle of elevation to the top of the building is 62 degrees. So you could reasonably assume that they mean from the ground up to the top of the building is 62 degrees. It doesn't say where they're measuring this angle from. But the fact that they've told us the height of the person suggests something. It suggests that they want us to measure the height of the building, so the angle of elevation from the top of that person rather than from the ground. Otherwise there'd be no point in telling us the height. Okay, so we actually have to measure the angle from the top of that person. So this is actually our triangle up here, and that angle is 62 degrees. Now this doesn't create any real problems because the distance along the base of this triangle is still going to be 18 meters. So we've still got a right angle triangle, and we know one side and we know the angle, so we can use Sohcahtoa to solve this. We've got 2 bits of information. If this is the angle theta, and this is the adjacent side to that, and we're trying to work out the height of the building, which would be x, then that would make this side over here the opposite side. So we've got the adjacent, and we've got the opposite, and we've got theta. That's a tan problem. So tan theta equals opposite over adjacent, and the angle is 62 degrees. The opposite is x, what we don't know, and the adjacent is 18 meters. So we can multiply both sides by 18 to get x on its own. 18 tan 62 equals x. Let's put that into a calculator. So 18 times tan of 62, close the bracket, that equals 33.85. So x equals 33.85. And that's going to be meters because our measurements were in meters earlier on. Now here's where we have to come back to the question and to our diagram. Now we worked out the height of this triangle here, but that's not the whole height of the building, is it? Included in the height of the building would also be this distance here, which is the height of the person. Because we measured from the top of that person, we've got to add their height to whatever we found this value x was, and then we'll have the full height of the building. So we've got to do 33.85 plus the height of the person, which is 1.8, and that's going to bring us up to 35.65 meters. Now that's important because that's going to change the answer. If we had have measured the height of the building without adding the person's height, then we would have chosen answer E. That would have been the closest one. But once we add in the person's height, the actual answer is C, 36 meters. 35.65 is closest to 36 meters. So the answer was C. So watch out when you see the person's height included in the question. That's a big clue that you've got to measure the angle from the top of that person, and then you've got to add their height to whatever. If you're measuring the height of a building or something like that, you'd have to add their height to that. Watch out for that. Okay, here's our next question. This is in the short answer section. So we've got a four-wheel drive vehicle leaving a campsite and traveling across a flat sandy plain in the direction of south 65 degrees east. Okay, so let's say this is our campsite. This is the starting point, and let's draw a little compass on that starting point so we can find our bearing. North, east, south, and west. We've got to go south 65 degrees east. So from south we go 65 degrees towards east. So our bearing is going to be roughly pointing like that, and this angle in here will be 65 degrees. And they travel along that distance for 8.2 kilometers. Okay, so and then it says it then heads due south for 6.7 kilometers. So they've obviously reached a point here, and then they've turned south at that point, so they've gone straight down for 6.7 kilometers to reach a waterhole. Okay, now the actual information we need to find is here. How far is the waterhole from the campsite? So here was the waterhole at the end of their journey. That's the waterhole was at the end of the 6.7 kilometers south. So we've got to work out how far it is from the campsite, which was back here, right down to the waterhole, which is there. Okay, so to work that out, here's what we're going to do. So we've got a triangle, and we know this side and this side of the triangle, but we don't know any of the angles. So in order to work this out, we're going to need an angle. We're going to need one more piece of information to use a cosine rule or a sine rule. Now it's pretty hard to see how we could ever work out this angle in here for the triangle, or this angle in here from the situation we're in, from the position we're in. That's not going to be possible. But to work out this angle, it might just be possible if we can do a bit of thinking. Okay, let's work out, let's imagine there's a triangle that goes across there. So it goes due east and then it goes south, and it forms a right angle at that point there. Well, we know this angle in here is 65 degrees. That was what was given to us at the start, that this angle here was 65 degrees. That means this angle here, that extends from our initial bearing up to the line of east, that angle in there has got to be 25 degrees, because they've got to add up to 90. That's a right angle, so it's got to add up to 90. So that's 25 degrees in there. Now for this triangle up here, if that's 25 degrees and that's 90 degrees, 25 plus 90 equals 115. And if the internal angles of this triangle add up to 180, which of course they do, then this last angle here has to be 180 minus 115, which equals 65. So this angle in here is 65. It's actually the mirror image of that initial angle over there. They're opposite each other, so they're the same. And that means that this angle in here, so this is our second point here, this angle inside here, if that's 65, this has to be 25, because together they form a right angle. They form this right angle here. Okay, so now we're getting somewhere. Now we've got this angle in here is 25 degrees. We've got part of that, we're trying to work out this angle here, and we've got part of it, we know that part's 25 degrees. And what do you think this part here is? It goes across and straight down. It's got to be a right angle. So this angle inside here is going to be 25 degrees plus 90 degrees equals 115 degrees. So that's great. Now we've got one of the internal angles of this triangle. Let's clear this up a bit. Okay, now let's use our new information, that angle is 115 degrees. Let's use that to work out this distance from the water hole. Let's call it point A up to the campsite, which we'll call point B. So that's going to make this angle over here angle C, and this side here will be side C. So this is looking like a cosine rule problem. We've got a side, we've got two sides, and we've got the angle in between those two sides. So to work out side C, it's going to be cosine rule is C squared equals A squared plus B squared minus 2AB cos of angle C. So let's plug our values in. Side A is going to be this side over here, and this is side B here. So 8.2 kilometers squared plus 6.7 kilometers squared minus 2 times 8.2 times 6.7 times cos of our angle is 115 degrees. Let's put that into a calculator. Okay, so here's our calculator. We've put in 8.2 squared plus 6.7 squared minus 2 times 8.2 times 6.7, finally times, let's find our trig functions, cos of 115. Whoop, we didn't put 115. 115, close the bracket and execute. And that gives us 158 point da 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 da. Now before we're finished, we've got to take the square root of both sides, because we've got c squared up here, so we've got to take the square root of our answer, and that'll give us the actual value for c. So let's find the square root function. Here it is. Put in the answer from the previous line and execute. And so c is actually 12.59. And notice how it's important, if I'd rounded off that previous answer 158.57, if I'd rounded it off to that and then taken the square root, this answer could have been slightly different. So it's very important when you're putting values into a calculator, put the whole thing in. Put this whole 158 point da 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 da, put the whole thing into the square root, and you'll get a more accurate final answer. So don't round off. The point is, don't round off early in your answer. Okay, so that's that one done. So we've found the distance from the waterhole to the campsite. That's part A done. For part B, what is the bearing of the waterhole from the campsite? Okay, to work out the bearing of the waterhole from the campsite, we've got to go from the campsite down towards the waterhole. So that's going to be along this bearing of line C towards this point A. So what we're really going to be asking for is, what is this angle inside here? Okay, now we knew the angle before up to this line, but we don't know the angle to this line. In order to work that out, we're going to have to work out what this angle in here is now, which we're in a much better position to do now that we know a couple more bits of information. So if we want to know this angle in here, which is angle B, then we're going to have to use the sine rule to solve this problem. So if we write out the sine rule, A sine A equals B sine B equals C sine C, if we write that out, the reason we can see it's the sine rule problem is because we want to know this angle B, we know side B, and we know side A, and we know side C and angle C. Side C was 12.59 kilometers. So with these bits of information, we're going to be able to enter in lots of stuff into the sine rule here and work out the angle B that we want to know. So we know lots of info about side C. Let's put all that in. Side C is 12.59 kilometers, and angle C is 115 degrees. For side B, or for the B part, we know 6.7 kilometers is side B. We don't know the angle B, that's what we want. And for this A part, we know that we've got 8.2 kilometers, but we don't know angle A, that's also unknown. Okay, so given that, we want to know angle B, and we've got all this C information. It's going to really help us to use this section of the equation. That's meant that in that case we've got 3 bits known and only 1 bit unknown. We can solve that. Okay, I've just rearranged things a little bit to make some more room. So we're going to solve this equation here. Okay, to make it a bit easier to put into the calculator, we're just going to try and isolate B. So to isolate B, we need to multiply this side by 115, and that'll get the 115 over here. So we'll have times sine 115 here. And then on this side we're going to do times sine B to get rid of the sine B on the bottom there. And we'll also have to do the same thing on both sides. So when we multiply both sides by sine B and sine 115, here's what we get. 6.7 sine 115 equals 12.59 sine B. Okay, we're trying to get B on its own, so we've got to get rid of that 12.59 there. They cancel out. 12.59 over the other side now. And lastly, we've got to get rid of this sign here by doing inverse sine. That cancels out the sine. Do the same thing over the other side. So finally, B is going to equal inverse sine of 6.7 sine 115 divided by 12.59. Okay, let's put that into the calculator. We've got inverse sine of 6.7 times sine of 115. Close that bracket there, and then that's being divided by 12.59, and we just need to close that final bracket. Okay, that tells us it's 28.83, which we want to convert to degrees, minutes, seconds. So let's go action, transformation to DMS, and put in the answer. And there we go. We've got 28 degrees at 50 minutes is this angle in here. We'll keep that there. This angle in here for B is 28 degrees and 50 minutes. But they actually wanted, in the question it asks for a bearing of the waterhole from the campsite. So we've got to go the bearing from that campsite down to the watering hole there. Okay, which is going to be this angle in here. Okay, so we've worked out angle B, we haven't actually worked out this angle here. That's what we've got to do now. And now we can do it, because we know this big angle here, the big angle that we were given at the beginning was 65 degrees from south up to this line here. And now we know the gap between that line and our actual bearing. So we just need to minus that angle B away from 65 degrees, and we'll have this angle in here, which is our bearing. So let's do 65 minus 28 degrees and 50 minutes. Let's put that into the calculator. 65 minus 28 degrees. It might actually be easier to use a decimal at this point. We'll use a decimal. 28.83627,307. And now we can convert that into degrees, minutes, seconds. So put our answer in. 36 degrees and 10 minutes. 36 degrees and 10 minutes. That's our answer for, well, actually that's not a proper bearing, is it? That just tells us the angle. So now we know this angle in here is 36 degrees and 10 minutes. But if we're going to convert that into a bearing, we've got to, let's do conventional bearing. It's going to be south. So we start from south, and then we go 36 degrees, 10 minutes towards east. So we'd write it out like that. So that's our answer for B. 36 degrees, south 36 degrees, 10 minutes east. Okay, there we go.